Hello everyone, welcome back. So in this video we are going to understand the reverse bit, right? And this question is really interested because it's having concept of bit manipulations. As I know, I have already solved this problem 2 years ago. So let's try to understand what the question is saying, that right? So have you ever looked at a binary number and thought that how do I reverse all the 32-bit without converting it into a string? So today we are breaking down Leetcode problem this 190 and we'll convert this into simple way or simplest way possible, that if you are preparing for the coding interview and the bit manipulation scare you a little, so stay with me and by the end of this video you will know this problem, right? So very first what we have given is we have given 32-bit unsigned integer, and what is our task? Our task is to reverse all 32-bit, that's it. Okay, so if the binary number for this one, if you'll represent, so if you'll see here, this is the thing we have, and the binary look like this we have. Okay, and you must reverse this binary into this binary, and then you have to return the decimal value of that reverse binary. And the very important thing here is it's always 32-bit. Okay, and even there will be a leading zero, right? So if there is a leading zero, it doesn't matter. This is not the string reversal, guys. Make sure that this problem is not string reversal, but this is a pure bit manipulation. Okay, so make sure that you understood everything and then you are doing the right thing. So now the question is, how do we reverse the bit efficiently, right? We know that we have converted into the binary 32-bit and then we have reversed it and then we got the decimal again. But the question is, how do we reverse the bit efficiently, right? So here is the mental model, guys, right? Let's suppose we are trying to understand how the intuition will work. So the thing that I'm understanding the question, and then we can say that if we take the, let's think about the mental model, how we should think about this type of questions, right? So very first, that if we say that if we take, let's suppose, the last bit of the number, okay, the number that we have given, right? If we'll take the last bit of the number, and then we add it to a new number. Okay, then if we shift, right, if we shift things, let's suppose carefully, right? Okay guys, then what we should do, we should repeat this thing 32 times. Okay, we'll make a loop and we can make 32 times, right? So think of this like picking a bit from the right side. Let's suppose we'll start from here and then we will rebuild the number from the left side. Okay, so this is a bit by bit reconstruction process and we can do by using these steps. So you pause this and try by yourself. So let me tell you how I'm thinking, right? So let's suppose that we have n is equal to a small one, we have 1 0 1 1 0 0, right? So we know that we have to process from right to left, right, like this. So this is 0, this is 0 1 2 3 4 and 5. So from index 5 we'll start here, right? So let's say in the step 1 we will extract, very first is 0. So let's say extract 0 first, means this one, then add into the result. So result is nothing but 0. Then in step 2 you will come to the next index, it is also 0. So we'll say okay, it's 0, so add into the result, this is 0 0, right? Similarly in the next step we'll say now we have is 1, so we'll extract 1 now. So the result will happen is, this is 1, this is 0 0 1, right? Then in the next step we'll say extract 1 again, right? So this will become 0 0 1 1, right? This is our result. Like this we have to keep going. Then we'll come to here. So this is 4, this is 0, we'll extract 0 here. So 0 0 1 1 0, and in the last we have 1 here. So we'll say 0 0 1 1 0 1. Like this we have to reverse it. So basically the key operation here is that we repeat this process 32 times. In the real problem we have here like these examples, and the key operation is that we will use, let's suppose, is n and 1 to get the last bit. Okay, if you want to find the last bit, right, if you want to get the last bit, you can say the get the last bit, you have to use this one. Then you need to make the space. So you will say okay, result, and one shift you have to take, left shift is 1, and you will make a space. This is called make space, right? Then again you need to move to the next bit. So you will say okay, move to the next bit like this. So I'll say you to keep a note of this, move to next bit. So like this we will use to move in the bits. So that's the entire trick, guys. You just get the last bit, then make a space using the result. One shift we will do, and similarly for the right shift you will do, and you'll move to the next bit, right? This is what we will do. So the very first thing you see that we have to use the result. So create a result and loop 32 times, so that very first you shift the result, right? And then you will make this one to extract the last bit and add it to the result that you will do, and then you have to shift n bit again, right? You have to shift n right, like that. Once the shift is done, you need to return the result that you have in the answer, like this. Okay, so let me show you how to develop this type of problem. Okay, so let me go here. Okay. So how I'm thinking, guys, very first, as I told you, we should take result, right? So let's think that we have int result. It's a very simple problem, so we can directly write. Okay, then we'll make a for loop, as I told you. Start from int I equal to 0, and I should be less than 32, right? So total 32 bit we have, so we'll go to 32 from 0 to 32. Don't do equal to. Okay, then we have result, and from result we have to make first a space. So to make the space you need to do like this, first one space. Basically we are making a space. Okay, then the result we have to say is like this. We will say, where we'll say n and 1, I told you, so we can add a last bit of the number. So how will you do that? This is called, we want to add last bit, right? Once this is done, we know that we have to move to the next bit, right? So to move the next bit, you just need to make a shift in the right, and which is equal to, we will say, is 1. It means we are moving to next bit. Okay, once these are done, guys, means we will repeat to 32 times, means we have some result now. So that result is nothing but is reversed. Oh, sorry, return. So that result is already reversed. Now we can say this will work, right? So let me check. Result. Okay, basically I think we used to do this one, right? Yeah, or it will add. Correct. Yes, so it's working. So this is what we have, guys, in this video. And in case you are struggling with anything, please let me know in the comment section that you understood or not. So the time complexity, guys, we know that we have to run 32 times, right? And it's a constant because it always runs 32 times, right? So it's not O of n, but it's O of 1, right? So time complexity is nothing but TC is equal to O of 1. Okay, if you'll talk, because why? Because you can say because it always runs 32 bits. Make sure that. Then if you talk about the space complexity, guys, it will become also O of 1. O of 1. Okay, so this is constant time and we are taking constant space, and this is perfect code for understanding, guys. So this is very interview friendly if you are understanding this type of problem and how to approach, right? So we should understand. There is another approach that you could use, like integer.reverse, but in interview don't do that because they will think that you don't know the bit manipulations. So better try with this, right? Very first go with the 32 bit, then make the result space, and there should be extraction of the bit. Let's suppose in this case we are getting one last bit each time, and then moving to the next bit, and then we are appending each time. Here we are basically appending. So this is called the good way and best approach, we can say, for this video. In case you are struggling with anything, please let me know in the comment section. And if you want to do the preparation in the structured way, you can join our online classes, and for that you have to ping in the WhatsApp. So that's all I have in this video, guys. Thank you so much for watching this video. I'll see you in the next one. Bye bye.